What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I want to show you how to solve exponential equations. All right, let's get right into the videos into the examples, because these may be rather long. Okay, so if I have 10 to the 2x power plus 3 equals 8. All right. And I need to solve for x, okay? Now, we want to solve this pretty much like you solve a multi-step algebraic equation, but we throw the exponential piece in and some other things like that. So, everything has to be balanced, so I need to get this term by itself. And I'm going to start off by subtracting 3 from both sides. That leaves me with 5, and then I'll bring down the 10 to the 2x power, okay? Now, according to my rules, if I actually take log base 10 of 10 to the 2x, and I want to do that to both sides, log base 10 of 5. Now, the rule tells me that this side I'm going to be left with just 2x. Okay, because 10 to the 2x power equals 10. Okay, so I'm going to be left with 2x. Equals log base 10 of 5. Now, I need x by itself. So, the opposite of multiplying by 2 is dividing by 2. So, I'm going to divide both sides by 2. That cancels. So, x is equal to the log base 10 of 5 divided by 2. All right. And I'm going to use the calculator here to put in the log base 10 of 5. All right. And I would suggest putting it in the calculator just like that. I could give you what the value of log base 10 of 5 is, but my approximation is going to be much better or much more accurate if I leave it like this. And that's going to leave me with 0.349. Okay? That's your first example. Let's get another example. We're going to do about 3 or 4 of these examples, all right, because I want you to see different ways. These are the equations that they show you. They come in different forms, okay? So example 2, I have 12 plus 3 times 3 to the 0.1x power, and that is equal to 16, okay? Once again, I need to get it down to just this term right here, 3 to the 0.1x power. All right? So, I want to take this 12 to the other side. So, let's subtract 12 from both sides. All right? And I have 3 times 3 to the 0.1x power is equal to 16 minus 12 is 4. All right? Now, this is the step that can be confusing. This is 3 times 3 to the 0.1x power. So I want to go ahead and divide by 3 here because I want this term right here by itself. So those cancel. So 3 to the 0.1x power is equal to 4/3. All right. Now we need to use the inverses so I can get that x by itself. Okay. So I need to get rid of this 3. And what I'm going to do for that is I'm going to say log base 10 of 3 to the 0.1x power is equal log base 10 of 4 over 3. That leaves me with 0.1x because those cancel. Is equal to log base 10 of 4 over 3. And now I'm multiplying here. So the opposite of that is dividing. So I need to divide both sides by 0.1. Divide by 0.1, and x is equal to log base 10 of 4 over 3 divided by 0.1, okay, which is approximately, when I put it in the calculator, 2.619, okay? Now, I know that's a lot, but go back through. If you have to pause, rewind, go back through the steps. We're doing all inverse operations. We're keeping the equation balanced, but it's just we're doing it with exponentials. All right, so this is your approximation. 2.619. Notice I keep this in this form because that's going to give you the best approximation. Okay. Let's see. And also, when you're doing these approximations, make sure different teachers or different whatever books that you may be using ask for approximations to 2 decimal places, 3 decimal places. So be mindful of that stuff right there as well. Example 3, I have 1.2 e to the negative 5x power. And that is equal to, plus, we have plus 2.6 is equal to 3. Okay? So, once again, we need to get this term by itself. Our goal is to get e to the negative 5x by itself. So I want to go ahead and I want to subtract 2.6 from both sides. Alright, so that gives me 1.2 e to the negative 5x power is equal to 3 minus 2.6 is 0.4. Alright, now what I want to do is I still want to get e to the negative 5x, so I'm going to divide by 1.2 on both sides. Alright, so that cancels. So I'm left with e to the negative 5x power is equal to 0.4 divided by 1.2. Now, I left it in this form for a reason. Once again, we're trying to get the best approximation possible because we're going to use these. We're going to have to use the calculator to find out these values. Okay, so now, in order to get rid of this, I need to take the natural log of both sides. Okay, so if I have the natural log of e to the negative 5x, that's equal to the natural log of 0.4 divided by 1.2, which leaves me here with just negative 5x. And I'm going to leave this in this form, natural log of 0.4 divided by 1.2. All right, and you can put that in parentheses. That's totally fine. That's what the calculator is going to do. In order to get x by itself, I need to divide by negative 5 on both sides. Those cancel. So x is equal to the natural log of 0.4 divided by 1.2 and divided by negative 5. Now, this value is actually a negative value. Okay, and so when I put that into my calculator, it's going to give me an approximation, which is actually 0.220. Okay, and so just to kind of step back for a second, this value right here, the natural log of 0.4 divided by 1.2 is actually negative 1.0987. But I purposely left it like this because your approximation, once again, is going to be better if I leave it in this form. Okay, so your digits are going to be slightly off if you actually put in the value of the natural log of 0.4 divided by 1.2. All right, please keep that in mind. That's very, very important. I've been doing this for years, and that's one of the things I always have to remind myself when I'm getting ready to teach this, because students will ask, hey, why are my digits off? And that is one of the things that will cause your digits to be off. Last example, we're going to do example 4, which is 4 minus 2e to the x equals negative 23. All right, we need to get e to the x by itself. So the first thing we want to do is subtract 4. Subtract 4, we get negative 2e to the x power is equal to negative 27. All right, I need e to the x by itself, so I'm going to divide by negative 2, because that's the opposite of multiplying by negative 2. All right, so those cancel. So now I have e to the x power is equal to, we're going to make this positive, 27 divided by 2, because a negative divided by a negative is positive. Now, I need to take the natural log of both sides again. So, the natural log of e to the x is equal to the natural log of, I'm going to keep it as 27 over 2, once again, for approximation purposes. Okay? And once I do that, that's going to leave me with x is equal to the natural log of 27 over 2. which the natural log of 27 over 2 is approximately, from the calculator, 2.603. All right. I know this one was rather lengthy. Do me a favor, if you need to, pause it, rewind it, go back over the examples. Thank you so much for watching. And if you have questions, please don't hesitate. Send me an email. Hit me up. DM me on Instagram at YG Math Tutoring. You can send me a message on Facebook at Young Gurus Math Tutoring. Like the Facebook page while you're there. And definitely subscribe to the YouTube channel. Share this with someone else. There's videos of all levels. I want to thank you for helping me just accomplish this vision of helping students all around the world with mathematics. Thank you so much. And once again, I've got the solution to your math problem.